Well, there are two big problems that the world faces. One is the environment, and the other is aging.
While growing old is totally natural, we're growing older than ever. And that means a greater proportion of our final years is being lived in poor health. We're more likely to suffer multiple age-related diseases, so more suffering and higher healthcare bills.
Age-related functional decline is the number one threat to the Western society.
1 in 3 children that are born today will live till they're 100.
For centuries, we've sought out mythical elixirs, holy grails, anything to put off the ravages of time, or at least cling on to our youth. Our fears and insecurities turned into big business. While recapturing our youth might be a bit of a stretch, scientists are now making serious claims about reversing aging.
We now have a scientific understanding of what's driving aging, and we have ways that we can intervene.
It's not anti-aging, it's reverse aging. It's taking the biology back in time. That's what we are doing.
Modern health advances such as vaccines, antibiotics, and sanitation have meant many more humans living well into old age. But those once lethal illnesses like infections or fevers have been replaced by chronic degenerative diseases.
You're aging actually as soon as you're born, even earlier than that. It just doesn't manifest as disease until it gets, you get into your 40s and 50s and later. But that later stage of life, usually an 80-year-old male has 4 to 5 different diseases. But what's happening is that all tissues and organs are getting old. And what that means really literally is that they're not functioning optimally anymore. And so you become susceptible to breaks, and cells lose their way and they grow crazy, and you end up with cancer as well. The last 5 years, 10 years of life typically are not something you'd wish on your enemies, let alone your loved ones. You don't get heart disease typically in a 20 or 30-year-old. And the reason is that the tissues are young and they can rejuvenate and heal. So if you took somebody who's 50, 60, 70, and if you could reverse their age, the majority of these diseases would just go away. And so aging is the root cause of these diseases. We've given them names, but really they should be manifestations of aging.
Professor David Sinclair and his team of scientists at Harvard are certain that the pain and suffering of old age isn't something we should accept.
What we want to do is to keep all organs and tissues healthier at the same time for as long as possible. If we can do it make a mouse or a rat, even a dog live like that and die quickly at the end. Can we do it in people? Can we do it with medicines? And what would the world look like if we could achieve that?
This world is probably closer than you think. Research in anti-aging has advanced significantly in recent years, mainly down to the establishment of the hallmarks of aging.
There's telomere shortening, there's loss of stem cells, there's DNA damage, there's senescent cells, zombie cells that accumulate. And then there's what I work on in part, which is called the epigenome.
Understanding the relationship between these hallmarks is the major challenge.
The epigenome is the control system for the genome. And we think that a large part of aging, and possibly the reason that other parts of the body go wrong, is that the epigenome becomes dysregulated. And what I mean by that is when you're a young child or an embryo, your cells are told to be a certain cell type. A nerve cell in the brain, when you're young, stays a nerve cell for most of your life. But over time, these nerve cells in our eye, in our brain, start to lose their identity, their epigenome becomes dysregulated. And that's what we think is driving a lot of the aging process. We work on this molecule NAD that turns on defenses against these hallmarks of aging. It helps telomeres get less short, it helps preserve stem cells, and it also, we think, slows down these epigenomic changes. And if you do give these NAD molecules to mice, they're much healthier. We showed a few years ago that they can run further on a treadmill, they get rejuvenated when they're old. Now, it's early days, we're not all going to suddenly be 30 years younger tomorrow, but the proof of principle has been shown. We can measure the age of a person accurately, biologically, and we can either take the cells out of the person, make them younger and put them back in, as some colleagues of mine at Stanford University have done, or we can genetically modify a mouse and turn on some what we call reprogramming genes and make those mice live up to 40% longer and be much healthier. Or what we did was we had a gene therapy where we turned on 3 genes that are normally only turned on in very young humans and mice. We decided to put them into the eye of mice to see if we could rejuvenate their eyes, and it worked. It really worked. Those nerve cells went back to a young age, they were healthier, and we restored the eyesight of those mice, those old mice. My colleagues and I have proven that you can reverse aging. It's just a question of when and how do we apply this to human disease and eventually to aging itself.
In Israel, researchers claim to have successfully reversed the biological aging process by using oxygen therapy.
We are taking the patient into hyperbaric chamber, increasing the pressure, and by increasing the pressure we are increasing the capacity of the molecules that can go into the lungs and through the lungs to the system.
The treatment has been shown to increase telomere length. Telomeres are the protective caps at the end of chromosomes, structures located inside our cells that carry our genetic information. As the human body grows older, the telomeres begin to shorten until they no longer protect the chromosomes, and that's when cells begin to die. The oxygen therapy also benefits stem cells, which serve as a repair system for the body.
The most powerful trigger that we have in our body that can stimulate stem cells is hypoxia, is lack of oxygen. Because when there is lack of oxygen, it serves as a signal to the body so to tell him, oh, there was hypoxia, now we have a problem. Let's start to replicate. We need you. We need you guys. Come along. Replicate and come along. So what we can do, we can take a person, hold his breath, stop his heartbeat. He will have hypoxia and then he will have stem cells. There is only one problem with regard to that. This is unhealthy. So we thought about it more and we said, okay, what the body actually sense? Does the body sense absolute values or does the body sense fluctuations? Does it sense relative value? So we have generated a certain protocol where we are taking the patient into the chamber, increasing their blood oxygenation to very high level, and then do a fast decline back to the normal value. And then going up and down again. We are generating fluctuation. And this decline from very high back to the normal is being interpreted by the body as hypoxia, as lack of oxygen, even though the body have extra oxygen. And by doing that, we are both replicating the stem cells and giving them the area where they can settle down and build up the tissue. You can see cerebral blood flow that is increasing to an area that previously didn't have blood flow. But we can also see the microstructure of the brain. We can actually see the bundles of the white matters in the brain. So we can see that combined with that and see the clinical improvement, whatever it is. Cognitive function, motor function, speaking capabilities, coordination, and things like that.
Results from one of Tel Aviv University's studies found that the telomere length of 4 key cells increased by over 20%.
For the first time in human beings, we were able to demonstrate that together with the improvement in the functional measurements, brain perfusion, brain microstructure, cognitive function, we can also reverse the aging at the cellular level. We proved that in human beings, not animal models, we can elongate the telomere length. This is DNA, sequence of DNA, and reduce the amount of the senescent cell, which is the aging malfunctioning cells.
The good thing is we're also learning that these processes that we're studying, these basically enhancing our own innate defenses against disease, they exist within us. And we don't need medicines to turn them on. We can skip a meal, we can become exhausted from running, we can lift weights, we can eat the right foods. And we actually know that these are the things you can do to enhance those defenses. So NAD, I mentioned, the NAD molecule that we're trying to make a drug, you can raise your NAD levels, not as much as a drug, but you can get those up just by eating less often. So if there's one thing I would recommend in midlife to do that could extend your lifespan, it's fasting. We find it's not so much how much you eat and what you eat, it's when you eat. And so you don't always be fed, don't always give in to those hunger pains. But other things happen actually. It's not all NAD. There's a process called autophagy or autophagy, which clears out the old proteins, the damaged proteins, and that only happens effectively when you're hungry. We've created our own nightmare because we've only addressed one part of the body at a time with the medicines, typically. And the number of people over 65 is over the planet outnumbers the number of babies under 5. And that's the first time in recorded and probably human history of the last few million years. Now, we're going to have a lot of older people. So what are we going to do? We can either let them get old and just sit around and wait to die, or we could keep them healthy and have vibrant people in their 80s traveling the world, looking after families, being productive members of society. And that's a much better case, both socially, for the individual, of course, and their families, but also economically. A number of countries now have more older people than young, and the country has to pay for those people. And whether they're going to be costing millions of dollars per family to look after, or they're going to be productive members and die really quickly, it's up to us. And it's a race against time. It's a worry. It really could bring down the growth of most countries.
Countries like Japan, Singapore and South Korea have already made large investments in automation and robotics to make up for the lost productivity in their aging workforces. Reversing biological aging might also go some way in tackling this problem.
The work that we just published, and a couple of my colleagues have published as well, shows that it is possible to reset the age of complex tissues in the body. We've seen the eye, my colleagues have done the brain, the spleen. We can partially take ourselves back to being younger without them turning into something horrible like a tumor. And that can be done safely, at least in mice. And I would say most likely in humans as well, because we've done human cells, at least in the dish, human brain cells. So what does that mean? That means that we have a reset switch for aging. And if we can safely turn that reset switch on in the body, it's an exciting future that means that diseases that were once impossible to cure or even treat, such as blindness, are now on the table as something we could tackle.
Targeting aging rather than individual conditions is gaining momentum in the scientific community. Improving our longevity might have a dramatic impact on our health, but also how fulfilled our lives are in our elderly years.